Beverage-can stove. From Wikipedia, the free encyclopedia. http://en.wikipedia.org. A beverage can stove is a homemade, ultralight backpacking stove. The simple design is made entirely from cans, typically soft drink or beer cans, and burns alcohol, typically denatured. Countless variations on the basic design exist. Pepsi cans are often used because they have a bottom shape that lends itself to securing the stove's inner wall, and because of this, the stoves are sometimes called Pepsi can stoves. The stove weighs 0.4 ounces, 10 grams, and will boil 2 cups of water in 5 minutes with 2 tablespoons of fuel. Total weight, including a windscreen stand, can be less than 1 ounce or 30 grams. Due to the low weight compared to commercial stoves in their fuel canisters, backpackers can save about 1 pound, 450 grams of pack weight with this stove. This advantage may be lost on long hiking trips, however, because the stove is less efficient and requires more fuel, especially when cooking for more than one person. Section 1. History and Design. The basic design dates back more than 100 years. It consists of a double-wall gas generator, a perforated burner ring, and an inner preheat chamber. A similar design was patented in 1904 by New York coppersmith J. Heinrichs. Trangia has been selling a commercial version of the design since the 1950s. Safe Sport marketed a stainless steel stove in the 1990s. Interestingly, the Trangia stove burner is made from brass, even though all the other associated parts that come with it are aluminum. A plastic bag is provided for the burner so that when packed away, the two dissimilar metals do not develop corrosion. The double wall acts as a gas generator, transferring heat from the flame to the fuel. This effect enhances combustion, producing more heat than other passive designs. The inner wall also creates a convenient preheat chamber for starting the stove. Once the fuel has warmed up, its vapor will travel up the hollow wall, pass through the perforations, and form a ring of flame. Vapor also rises from the center of the stove, but will pass through the ring of flame for efficient combustion, as long as a pot is over the stove. Section 2. Aluminum can construction. The stove is made from 2 aluminum can bottoms. An inner wall is cut and rolled from can material. A ring of holes is pierced in the top with a pin. Parts are glued with high-temperature epoxy or sealed with thermal foil tape. Total height is less than 2 inches, 50 millimeters, though dimensions can be increased to hold more fuel or decreased to take up even less space. The choice of aluminum has several advantages: lightweight, low cost, and good thermal conductivity to aid vaporization of fuel. Alternative construction materials have been used, including stoves made of tin cans such as cat food tins, tuna cans, and juice cans. The basic design is very similar. Windscreens stands can be fabricated from tin cans cut to size and with ventilation holes added. Section 3. Operation and Performance. The stove is designed for 1 or 2 people. When used to cook larger meals, greater than 2 cups or a half liter, it is less efficient than a more powerful stove that delivers more heat to a pot. This is because a longer cooking time is required, during which more heat is lost to the surroundings. A more powerful, pressurized version is shown below. Operation. To use the stove, a small amount of fuel is poured into the stove and ignited. The pot is then placed above the stove on a windscreen or stand. The flame is small at first, only burning from the inner chamber. Once the fuel has warmed up, requiring about 1 minute, its vapor will pass through the perforations and form a ring of flame. Enough heat from the flame is passed to the fuel to maintain full combustion until fuel runs out. The stove should not be relit unless it is fully cooled. Otherwise, flare-ups or explosive combustion, in the case of a pressurized design, may occur. Ratings. Heat output, approximately 4,800 BTU per hour, or 1,400 watts. Time to boil 2 cups, 500 milliliters, approximately 5 minutes, less than 2 tablespoons or 30 milliliters of fuel. Time to boil 4 cups, 1 liter, approximately 12 minutes, less than 3 tablespoons, 45 milliliters of fuel. Burn time, approximately 9 minutes with 2 tablespoons, 30 milliliters of fuel. Burn time, full, approximately 30 minutes with 5 to 6 tablespoons, 75 to 90 milliliters of fuel. Comparison to other stoves. The stove can outperform some commercial models in cold environments where propane and butane canisters fail. Ronald Muser, in long-distance hiking, surveyed hikers on the Appalachian Trail and found that this stove was the only design with a 0% failure rate. Fuel usage, by weight, is about 50% greater than a Peak 1 or MSR pocket rocket, although these stoves use gasoline and the can stove uses alcohol. The can stove saves about 1 pound, or 0.45 kilograms, of weight over these models for an overnight hike. The weight savings is lost for hikes greater than 1 week due to the additional fuel usage. Other attributes of the beverage can stove are its nearly silent operation and suitability as an emergency backup. Denatured alcohol is a relatively environmentally friendly fuel that doesn't leave soot, though it is toxic to drink. Pure ethanol is rarely used as stove fuel, since, being drinkable, it is usually subject to liquor tax. Denatured alcohol is commonly available at camping outfitters and hardware stores. These stoves operate well on 90% isopropyl alcohol, marginally on 70%, and not at all with 50%. Unsealed alcohol stoves can be inherently dangerous, since spilling is possible and the fuel burns with a nearly invisible flame. Trangia offers an anti-flashback fuel bottle with auto shutoff pourer. Section 4. Variations. Standard. The classic ultra-lightweight backpacking stove, designed for 1 person, lighter than commercial models of the same design. Inverted 2-piece, smaller and lighter than the standard version, difficult to fill. Side burner, doubles as its own pot stand. Holes are in the side. A tight-fitting pot can increase fuel pressure. Pressurized, a more powerful version, but heavier and more difficult to make. The stove is sealed with a thumb nut after filling with fuel. An additional base is used to hold fuel for preheating. Section 5. References. 1. Stove and fuel comparisons. Bushwalking.org. 2. U.S. Patent 560319, WJD Mast, 1895. 3. U.S. Patent 766618, J. Heinrichs, 1904. 4. Muser, Roland, Long-Distance Hiking, Lessons from the Appalachian Trail, 1997. 5. Weight comparison of beverage can stoves versus some commercial stoves, hikinghq.net. 6. Berger, Karen, Hiking Light Handbook, 2004. Section 6. Consult also. Portable stove. Hiking. Camping. Cooking on a campfire. Sterno. Buddy burner. This sound file, recorded January 19th, 2006, and all text in the article are licensed under the GNU Free Documentation License, available at www.gnu.org/copyleft/ fdl.html.